Alright class, so in lesson 2, evaluating functions and function notations. We're going to look at some key things that we need to know about evaluating these functions and function notations, and then we're going to get into our examples. The first thing we need to know is that a function notation is a way to show what the process between the input and output of a function is. So if you don't know, input and output are x and y values. Input will be your x, output will be your y. Now we're going to look at this symbol here where we have f parenthesis x close parenthesis. Now that reads as f of x, okay, where the name of the function is the input, the x is the input, and the entire f of x is the output. All right, so let's go back through that again. So this right here reads as f of x, where the name of the function is the input. Okay, x is the input and the entire f of x is the output. So if you notice that in the parentheses there's an x, all right, that x is the input value. So what we're going to be seeing when we start to solve these is that they're going to put a number in that parenthesis. And with that number in that parenthesis, we're going to use that to replace the x value in the equation. And that's what we're going to use to solve. And that's how we get our output. So the entire f of x is the output. That's really what they're saying is the answer. That will be our answer. Okay. Now, f of x is the same as y. So in math 1, what they do is they take y equals and they replace it with f of x equals, or it could be g of x. It can actually be any letter, but they just replace the y with a function notation. Okay, because in math 1 we do more function than we do like regular equations with y equals. Okay, so all they're doing is taking the y out and replacing it with f of x, which is a function notation. Okay, just to give you an example, you see here how we have y equals 3x plus 2. We're just going to replace it, and now it says f of x equals 3x plus 2. They are the exact same thing. Okay? Now, when we look at an expression like that, a function notation with f of x equals 3x plus 2, we'll notice that the f of x, as we said before, is the same as the y value. Other names that it can be called is the range, output, and y value. Okay? Now, all of the f of x is an output. No matter what is it called, no matter what the other names are, all of f of x is the output. Okay? And then we're going to look at the actual x value, whether it be in the parenthesis or the x value that's in the equation. Now, whatever they put inside the parenthesis is the input. Okay? So if they drop a number 2 in there, that is the input. So I have to input 2 for every x that I have in my expression or equation. Okay? So just to give you an example of what I mean, here we have an example. It says if f of x equals 2x plus 4, then find the value of f of 9. F of 9. Now if you notice that they put this 9 on the inside of the parenthesis, and if we compare it to the other one, this x here, really what they're saying is that 9 is x. So I'm going to take whatever they told me to put as x, which they replace x with 9, which is 9. I'm going to put it into this problem. Okay? So if you notice in the problem, basically f of x and f of 9 means you replace x with 9. Alright? So that's what I did. So I wrote my problem out. I put my 2. I put a parenthesis. Replace x with 9 plus 4. Okay? And then 2 times 9 gave me 18. Then I have my plus 4. 18 plus 4 give me 22. So that is how we're going to be evaluating functions. They're going to give us a number that we have to plug into the equation, and then we take that and solve. Now that we have a background or a little bit more information about it, let's look at some examples. Alright, so looking at our first example. First example says, let f be the function defined by f of x is equal to 18 plus 2x. It says, what is the value of f of 5. So when they tell me what the value is, like here, this means we're going to replace x with 5. Okay? So that means every x in the equation is going to become a 5. So if I do that, that's going to give me 18 plus 2 instead of x. I'm going to put a parenthesis and I'm going to put a 5 in there. Okay, so that means if I go through my operations, there are two ways I can do it. Now, I have noticed that there are going to be non-calculated questions and calculated questions, okay? So we kind of got to do both so we can have an understanding, but 2 times 5 is going to be 10. And then I bring down my 18. 18 plus 10 will be 28. So all we did was take what they told me f of 5 is, which is the x is 5, and we replaced x with 5. So when I did that, I replaced the x in the equation, which is right beside the 2. And then I started solving. So 18 plus 2 times 5, that gave me 18 plus 10, which is 28. All right, so now let's move on to example 2. Example 2 says, what is g of negative 3 in the function g of x is equal to 4x squared plus 3? So in order to solve that, they told us what to replace it with. So in this, what you will see is that we got to replace x with a negative 3. Okay, so that means this negative 3 will go here. All right, so let's write it. So we're going to do 4 parentheses negative 3. Now that x had a exponent attached to it plus 3. So now we can go solve it. Starting to solve it, what you would do will be you would take negative 3 squared, because you got to do order of operations. Please excuse my Deion salad. Parentheses first. Negative 3 squared, that'll give me 9. And I bring everything else down. Okay, so when I multiply that, 4 times 9 will give me 36. And then I bring my plus 3 down. And then 36 plus 3 be 39. So the answer for example 2 is 39. Now let's move to example 3. In example 3, it says a function is shown below. G of x is equal to negative 2x squared plus 3x minus 9. What is the value of g of x when it's negative 3? So when we're looking at the problem, we got to remember that they told me what to replace it with. So I'm going to replace x with negative 3 in this one. Okay, so I'm going to take and fill in every x in that equation with the negative 3. So that's going to give me negative 2 times negative 3 squared plus 3 times negative 3 minus 9. Okay, so I start going through my operations. I got to do exponents first. Well, parentheses, then exponents, but we have an exponent with the parentheses, so that's negative 3 squared. That's going to give me 9 again. And then I bring my negative 2. And then I got 3 times negative 3, which is negative 9. So I bring down negative 9, and then I bring my other negative 9 down. Okay, now I got to do the other one, which is negative 2 times 9, which is negative 18. And then everything else really just drops down. Okay, and from there, we're going to take care of the next step, negative 18 and negative 9. That's going to give me negative 27. And I bring this other 9 down. Now, I am doing all this without a calculator. Okay, you can type it in Desmos once you get it all filled in exactly the same way that you have it, and it should give you the answer. Okay, but in this one, we got negative 27 minus 9. That's going to give me negative 36. So that's the answer that we got for example 3. Now let's move to example 4. In example 4, it says two functions are shown below. We have f of x is equal to 6x plus 3, and we have g of x is equal to 3x minus 2. It says, what is the product of f of g and g of negative 4? Now, one key word that I saw was the word product. Product means multiply. So we eventually will have to use multiplication. All right. But when we look at f of 3, this is talking about the function f. Okay. Function f, we're going to replace x with 3. And then for the other one, function g, we're going to replace x with -4. Okay, so let's go ahead and write those expressions out with the numbers being put where they're supposed to go. So like function f, we're going to put 6 times 3 plus 3. And then for function g, we're going to put 3 times -4 minus 2. Okay, so 6 times 3 is 18. 18 plus 3 will give me 21. 3 times -4 is -12. And then minus 2 will give me -14. Now they said that we have to take the product of those two. Okay, so we got to get the product of those two. The product means we got to multiply the results. So we got to do 21 times -14. And when you do 21 times -14, you get -294. So the answer for example 4 is -294. Now let's move to our last example. Alright, so in the last example, it says that the population of bacteria M after X minutes is represented by the function M of X is equal to 51 times 1.03 raised to the X power. The population of bacteria P after X minutes is represented by P of X is equal to 29.05 raised to the X power. It says what is the approximate difference between the populations after 3 minutes. So every time we solve problems like this, we need to go and underline what we feel is important. Okay, they said approximate, so the answer we're going to get is close. We see different, and we see 3 minutes. So now difference in this means subtract. So whatever we get as a result from each of the populations, we're going to have to subtract it to get our final answer. Okay, so if I start filling in, let's say, our M of X. If I fill in what I have, we got 51 times 1.03 raised to 3 minutes. And then if I do P of X, we're going to do, it'd be 29 times 1.05 raised to 3 minutes. Now we're going to go to Desmos, because these type of problems are kind of hard to solve by hand. But if we can use a calculator, why not go and use it? So let's go to Desmos, and we're going to type in our results. So when we type in our results, what we're going to get is we have 51 parentheses 1.03. We're going to close parentheses, and we're going to raise it to, we're going to hit the AB button, raise it to 3. Okay, and then we're going to drop down, do a new line. We're going to do 29 parentheses 1.05 close parentheses. We hit AB again, and we'll raise that to a 3. So now that we have our results, we're going to use 55.7, and we're going to say what, 33.6. Okay, so now that we have those, let's go back and we do our subtraction. So we said 55.7, and we got 33.6. So now if we take and subtract those, when we take and subtract 55.7 from 33.6, we're going to get 22.1. So the final answer for our last example is 22.1. Now that we have covered everything dealing with evaluating functions, we have to remember that we have replaced y with a function notation, and they can use any letter, but the most common is f of x. And as you've seen in examples, they use m of x, p of x, g of x. So they can use any letter. And what they're going to do is they give you an equation and they'll tell you what they want you to plug into that equation. Okay, so once you get to that, you'll plug it in, you'll solve the expression with the number that they told you, and then you get your final result. And that's it. That's how you evaluate functions. If you have any questions, don't hesitate to ask.